So we're going to do something a little bit different instead of starting right into the notes. So first of all, what do we know about triangles? You've been studying triangles for quite a while, especially in high school, but you even did in elementary school. So if I look at these balloons for a second, one of the things that came across, one of the questions when we were working with the Pythagorean theorem was an isosceles triangle. Well, an isosceles triangle means that I have two sides that are equal, only two, and it also means that those two angles are also equal. So those are things that we learned a long time ago. Right triangle, we know that we have a right angle in it. When we talk about an equilateral triangle, we know that we have all three sides and all three angles are going to be equal. Now, the total number of degrees in a triangle, well, that is 180. Those are pieces of information that I should know. A scalene triangle is one where none of the angles are equal to each other. And finally, Pythagorean theorem, which we've already studied, we know that the hypotenuse squared equals the sum of the squares of the other two sides. So this is information that you have in front of you right now that is considered common knowledge. Okay, and for most of you, it is common knowledge. So let's take a look at our goal today. Our goal today is I can use primary trig ratios, and that is SOHCAHTOA, okay, sine, cos, and tan, to determine the side lengths of right triangles. So this lesson is just dealing with side lengths. There's another mini one dealing with angles. You can watch both of them if you so wish to complete all the work. That's totally up to you. So first of all, we know that the study of trigonometry is actually the study of measurements of triangles, everything to do with measuring triangles. So this is a review of what you should already know. So I'm assuming you know that. So the three trig ratios are, first of all, sine, we use the short form SIN. So we don't say the sin of an angle, because angles don't have sins. We say sine, because SIN is short form for the word sine. When we're talking about cosine, its short form obviously is cos. And tangent, its short form is tan. The other thing that we see a lot in trig has to do with this little symbol here, which is a Greek letter called theta. Okay, and really all it is a variable just like x. So the Greeks used theta because that was probably one of their letters. It was one of their letters in their alphabet, so it didn't seem strange to them. Now also when we're labeling sides of triangles, when we're talking about this, we're talking about a few different things. Okay, obviously we're using capital letters in our corners, no big deal there. But when we're talking about using SOHCAHTOA, okay, the primary trig ratios, we have to label the triangle according to some pieces of information. Just like the Pythagorean theorem, we knew that we needed the hypotenuse. So usually what we do is we just usually put h for hypotenuse, but here we have it's directly across from the right angle. And then we have the other two sides that we talk about. We usually call one opposite and one adjacent. Now how do I determine which one's which? Because I have two sides. Do I just guess? No, there's no guesswork here. So in this case, there's a theta that's been marked. Sometimes it's the angle I want to find, and so I'm labeling my triangle according to that. Or in other cases, that's the angle. They gave me the actual measurement of that. So then I want to label my triangle according to that. So directly across from this theta is directly opposite that theta, opposite side. Okay? And finally, the leftover side is the adjacent. Now, you might say, do I have to put that? Do you know what? It takes less than 3 seconds to find your hypotenuse, put H, find your angle, O, and put an A. It really doesn't take that long, and it's well worth your time to do that. Now, you also know that you had to learn SOHCAHTOA. Now, the reason, those are 3 formulas. They're 3 mini formulas. So this tells me that sine of a theta of an angle is equal to the opposite side over the hypotenuse. And this is cos of a theta is equal to its adjacent side over its hypotenuse. And finally, the tan of a theta equals its opposite over adjacent. Okay, so again, that's review of things that you should already know. Now, let's take a look at determining side lengths. Now, on the right-hand side, I have kind of a step kind of thing that you can write down. So, first of all, the question asks, determine the measure of the missing sides. I have two missing sides. I have one here, and I have one here. Now, obviously, the one that's labeled an H, I suppose I could find it, but I might want to find the X maybe first. It doesn't really matter. But first of all, I need to label sides of the triangle with HOA. Well, I actually already started, right? There's my H. Opposite. Okay, so this time they gave me 65, so it becomes my angle. So that's the one that I want to label opposite. So across here would be opposite, and obviously this would be adjacent. After I do that, I write SOHCAHTOA. So I'm going through the steps. You maybe eventually do not need all these steps, and that's fine, but this works for everyone. Then underline the letters of SOHCAHTOA with what you have, and I believe it should say what you have and what you want to find. So the only side that I have is the opposite side, and depending on whether I'm finding H or A, I think I'm going to find A, I would use in this case TOA. So I choose the ratio which has two letters underlined, and that's tan. And then I calculate the side to 1 decimal place. So the first thing I'm going to do, I've determined my tool, which is going to be the tan ratio. I write down its formula, and I substitute the information I know. I know theta is 65, and my opposite is 12, and I'm finding x. So the next thing I need to do is I need to cross multiply and divide. So you can see that I have tan of x. Tan of 65 times my x equals 1 times 12. I know my x has to equal 12 divided by the tan of 65. And I'm just going to move this up a little bit for you and actually move this whole question down. I know you can't do that on your paper, but I'm sure you're writing thinner than me. Okay, so we bring up our calculator again. Now I just had a hand calculator in front of me. And so I'm doing, I get approximately it said to 1 decimal place, 5.6. And I don't know if it's centimeters or whatever, so it's units. Oops. So if they don't give you whether it's centimeters, meters, and you want full communication marks, then I would use units. Now, if I wanted to find h, I could use trig again, or I could use h squared equals a squared plus b squared, which I think I'm going to do. So we have our 5.6 that we calculated. We also have our 12 that was given, and when we calculate that, 5.6, so you have to listen to me doing this because I don't have it all calculated. So I end up with 175.36. We need to take the square root of that, and we get 13.2. And again, that makes sense. It's the hypotenuse, and that number is the largest of the two that we have now. Okay, one more question. Okay, so this time I think we're just going to find y instead of all of them. Okay, same thing. First step, I need to label my triangle. Okay, so here's my hypotenuse. Opposite of 25 is opposite, and then I have adjacent. Again, I'm going to write down SOHCAHTOA. Some of you are probably able to do that in your head, and that's fine. I have 88 feet, which is the opposite, and I want to find the hypotenuse. So you can see right away we're going to use this sine ratio. So we have sine of a theta equals opposite over hypotenuse. So we have sine of 25 equals 88 over our y. Again, we're going to cross multiply and divide. So that would be y sine of 25 equals 1 times 88. Divide both sides by sine of 25. And when we do that, we end up with our calculator, 208.2 units. Oh, actually it's feet, because we know that. Okay, so that's it for this lesson, so you can move on to the next one after.